Alright, so we're going to look at find inverse functions and relations. Now, when you first started with algebra and you were talking about functions, you learned about something called the vertical line test. So the vertical line test was where I could take my pencil or pen or whatever utensil I was using, even my hand, and if I drew a line that stood up and down, then we would say that the relation is a function because the line that I'm drawing up and down would never touch this function in more than one spot. Likewise, we have something that we do, it's another type of line test, to test if a function is an inverse or if the function presented is its inverse of the other function. And that's called the horizontal line test. Now, we basically say the same thing. If the line, for instance, say I had something like this, and I drew a horizontal line, I could say, oh, this function has an inverse. Versus if I drew something like, say it was a quadratic that was reflected, and I drew a horizontal line, it touches a horizontal line here and here. So we would say that this function does not have an inverse. So notice that was our first question. The graph below shows a function. What kind of function? A quadratic function. Is its inverse also a function? Well, if I complete the horizontal line test, my answer would be no. The graph below shows a function. Is its inverse also a function? Let's do the horizontal line test. If you look, this is called a sine graph. You don't know about this in trigonometry, but I'm doing a horizontal line test. So its inverse would not be a function. The graph below shows a function. Is its inverse also a function? Let's do the horizontal line test. The answer would be no, because it hits here and here. The line hits here and here. Now let's look at this one. We have a linear function. If I draw a horizontal line here, or here, or here, or here, well, that horizontal line does not hit this function in more than one spot. So its inverse is definitely a function. Now, find the inverse of a function. Write your answer in the form of ax plus b simplified any fractions. Let's see how we would do that. If you go back in your mind to when we were talking about inverses at the beginning, we talked about if we had an equation, how to find the inverse. What we did was first switch the x and the y and then solve for y. So I'm going to put my x here in front of the equal sign. I'm going to keep my negative and I'm going to put the y over here. Well, now I'm going to solve for y. So to do that, I could divide by -1 on both sides, and that would give me negative x is equal to positive y. Okay, and they're just asking me to write this, so I would just write, or you could turn it around if this confuses you, y is equal to negative x. Okay, so find the inverse of the function y is equal to x minus 3. So we're going to follow our same steps. Switch the x and y, so x comes here, y comes here, minus 3, I'm going to solve for y. So I'm going to add 3 to both sides of the equation, and I get x plus 3 is equal to y. So this equation would be the inverse of this equation. So we've got x plus 3. Seventh question, y is equal to the cube root of x plus 3. So switch, so I've got x is equal to the cube root of y plus 3. So I'm going to subtract 3 from both sides of the equation. That gives me x minus 3 is equal to the cube root of y. Now remember, the only thing that can undo this root is to raise it by the power of 3. So I'm going to raise both sides of the equation to the power of 3, and I get x minus 3 cubed is equal to y. Now let's see how they're asking us to write this. Write your answer in the form of a times bx plus c cubed plus d, where a, b, and c and d are constants. Simplify any fractions. I don't have any. So we're going to try to test this together. Hopefully we get it right. So x minus 3, and out here I'm going to put cubed because that's what y equals. Yay! Go forth and make it 100.